Let's go for solution now. We are already done with the necessary setup, which you can see in the previous video of this playlist. So now double click the solution. As you can see, a new window will pop up with the name of define run. So in the submission type, let's go for direct start. We'll immediately be starting this solution. And in the run mode, we have serial, Intel MPI local parallel, as well as Intel MPI distributed parallel. Serial means the solver will perform the iterations serially one at a time. But if you go for the MPI local parallel, then two or more iterations can be performed parallelly, making the solution faster. So let's go for Intel MPI local parallel. Now you gotta choose the number of partitions, means how many cores of processor to employ parallelly, which will help more number of iterations to run at a time. So for that we need to check the number of cores we have in our processor. So let's go to task manager, and in this pulse setting icon, this performance, we can see the number of cores here. I have 8 cores processor, so let's employ 4 cores for fast solving and better performance, and let's leave the remaining cores for other functions of this computer, and let's go for run. Now the solution has started, as we can see the number of iterations slowly increasing, and in this graph interface we can see 4 lines with 4 different colors. The lines in green, blue, and yellow colors are showing the convergence of momentum, while the red line is showing the convergence of mass. While doing the setup, we have kept our convergence point or residual point to be 1 into 10 to the power minus 5. So this solution will be running until the residual point of 1 into 10 to the power minus 5 is attained. For that, all these 4 lines need to cross this residual point. And in the case that all these 4 lines don't cross our residual line of 10 to the power minus 5, we will only have the maximum number of iterations 500, as we have kept in our setup. So this solution will end with either these 4 lines touching or crossing this residual line, or reaching of 500 iterations. In this graph, in x-axis, we can see the accumulated time state, which means the running number of iterations. And in the y-axis, we can see variable value, which will denote the residual points. This 1 into 10 to the power minus 5 is our residual point. So once all these lines cross or touch this line, the solution will be over. Likewise, we will have the graph for turbulence, as well as wall and boundary scale. In this graph, the residual point has already crossed our value. And if we had kept the residual point 1 into 10 to the power minus 4, then our solution would have already completed by now. Lower the residual value, higher will be the accuracy of the solution. You might remember solving of the algebraic equations in our high school in number of iterations. It is quite the same method, as the solver is also solving the algebraic equations in number of iterations. Okay, now you can see the solution as completed, as all these lines have already crossed or touched this residual line, and we have completed the solutions in 55 iterations, and we have a message here saying that all the target criteria has reached. So now the next thing we'll be doing is going for results. This is the post processing section, and we'll be seeing our results in next video.